Hey guys, what's happening? Everybody doing all right in there? I know I'm doing another live stream. I'm sorry, but there's stuff going on, guys. Sometimes I won't, do a show for a couple days. Other times, like right now, when it's extremely busy on the sun, I'm going to be here quite a bit. I will be keeping this short. I just got through doing a live stream over on the lifeboat. Go check it out if you've never been over there. Please go check that out. It's awesome stuff. A lot of you guys already know. So yeah, let me make sure we're good here. Okay, yeah, we're good. We're at least doing something here. Can everybody see me? Somebody give me a 5 for 5, please. If you would, just give me a 5 by 5 in there, so we can just yeah. Let's see here. Hey Anna, hey Robert, Rebecca, Dorian, Stephanie, Tesha, Jerry. Good to see you. Renee Woods. Hey Tina, Darcy, Deb, Lori, E-Rock got the cookie, baby. Dodgette. That's right. Deb, what's up? Stephanie, Dolores. Okay, thanks guys for the 5 for 5, guys. All right, so I'm going to kind of just go through this because there is a lot to talk about. A little, this is becoming quite active time, and it's happening really, really quick. So I do think we're going to be seeing some conditions that we're going to have to pay attention to. Okay, whether it all pans out to be anything big at all, that's again, nothing's 100%, but the chances of that is actually coming up right now. It's not often that I've been able to show you this with the X-ray flux. This is flares, and to see what it looks like right there, it looks almost like almost like an EKG machine. It's really up and down like that. But you guys have heard me talk about we get a base level of X-ray, right? The sun's always producing X-ray, and it typically comes from the sunspots. It's more intense when it's around the sunspots. But when we start getting more and more, that X-ray, the baseline kind of rises. Back in solar minimum, it was way down here. And it was even down here just like a week ago. But now the baseline is almost at sea level. Okay? C class, I should say, not sea level. But anyway, you can see where it's, we're staying at a C class flare level in X-ray production at all times right now. Okay, so it doesn't take much of a flare at that point to push you up into M class, and then it has to be talked about X class, because there's some possibilities of this now. And I'll show it to you guys. And I ain't saying that it's going to happen. I'm just saying there are possibilities of that, and I would be remiss not to tell you guys. But as you guys can see, just look at this. I mean, we got 1, 2, 3, 4. I doubt that one's an M class, but that's 4 M class, almost 5 right there. We just had another flare right here, and a lot of this is coming from the same sunspot. Right now, don't let it fool you that we have no geomagnetism right now. We're just simply not getting any space weather at this point. It's coming. I promise you that. It's coming. Now, whether or not it gets to be, again, to those kinds of levels, it's yet to be seen. So let's go over this real quick. And first off, what I'll do here is I'll show you their forecasting. I showed you guys this earlier, and earlier they were just calling for, if you go back and watch my earlier video, I showed this, and it just said G1 right here. The rest of the stuff, the G1 at 2100 here on the 17th wasn't there. They were only calling for a G1 storm for a very short amount of time. Now we got G1 kind of pop out of storm conditions, G1, G2. So G2 isn't catastrophic stuff, but it's an uptick, right? So now we got G1, and I look for this to change some more. We can't see the 19th yet. There's stuff still blowing off the sun. And it's coming from that same sunspot, or the multiple sunspots, but the main culprit is the one I showed you guys earlier. This one. Okay? So, we're going to go ahead and skip down here and show you, this is the absorption model. And this is when we talk about flares, this is where we go to look and see how much is absorbing right here. So I'm going to push play. We'll let this run for a minute, but watch this. Bam. bam, 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 bam. It's just, yeah, it's active. I'll just say it that way. And this isn't like extremely strong, okay? It's not. Now, the X-rays from the flares have already hit and gone, okay? Now we're looking at geomagnetism. Something else I need to bring up here before I move on also is the chance of a radiation storm, which if you look here, S1 would be the first tick of that. They've actually raised the chances of that to 10% now. And the reason why is because we have all this extra activity. So there is a chance of a proton storm, basically, is what a radiation storm is. It's just highly charged protons, and it blasts into us, and it's radiation. Usually, you know, if you go back and watch my last video, these here were reading like 1%. Okay, so for the next 3 days, we're looking at 10% chance of a radiation storm also. Now, you know, is it going to be catastrophic at an S1? No. But it says S1 or greater. You know, and again, guys, at this point, we're not looking at anything like catastrophic, but we need to be paying attention because we're going to be having a lot hit us in a very short amount of time. And if anything big like X-class stuff pops off, we're going to have to pay attention. Again, I'm not saying it's going to happen. I'm just saying that those kinds of things are a possibility. Now, I had somebody ask me about AURORA. This AURORA is not going to increase until those CMEs and solar winds start to impact. Okay? So this AURORA is not caused by X-ray. It's geomagnetism that gets in. It excites oxygen, nitrogen molecules, all those molecules that we have in our atmosphere, and they get in easier at the poles. That's why we see them here. That's why we see the AURORA here. So those particles get in, they excite these molecules, whichever molecule you want to talk about, and then when it goes back to, when it's transferring back to it's always trying to get to a balanced state. Okay? That's what the molecules are doing. They're trying to get back to that state. And in that process is when they put off their glow. So oxygen will typically give you a green color. Nitrogen gives you like pinks and reds. And there's other ones involved there too. But just know that that's actually how AURORA works at a basic level. But for now, until geomagnetism gets here, these AURORA are going to stay like that. Now, once these things start impacting, yes, we're going to see an increase in this. The AURORA photographers are probably just, you know, chomping at the bit wanting to get out there, man. I mean, really, really. Hey, Bubba, you in here? Good to see you, Bubba News. Good to see you. Oh, man. Okay, anyway. That coronal hole, okay, yeah, I know it looks like a question mark or whatever you want to call that. But this was pretty sizable at one point here, and it still is. I mean, up here even, it's still letting charged particles out. So that's adding to it also. So let's check out these flare players, I should say. Now I'm going to go into the magnetism a little bit here because I kind of rushed through it in my last video. But I want to explain that to you guys because I don't do that very often on this particular one, and for the life of me, I don't know why. Sometimes I think I just forget. So I apologize for that, because, I mean, this is something that everybody really needs to understand and learn. What this is it's going to show you polarity on the sun. Okay, and this is a sunspot. That's a sunspot. That's a sunspot. Now, this is back on the 13th. So we're going to go ahead and go to present time here. And remember, in a solar cycle, you have a specific polarity. If you notice in the northern hemisphere here, you got negative, which is blue, positive, which is red. If you go to the southern hemisphere, what are you going to have? You should have the opposite, right? If it's not opposite of that, that means it's part of that 3% of sunspots that have the opposite polarity when it really shouldn't. So let's go ahead and get that moving again for you. We'll get you back here to present time here. Okay, so what I want you guys to watch is how fast this sunspot here, because this is really the one that's blowing all the stuff right now. Watch how fast it develops. Okay, now And I know that that doesn't look real impressive unless you understand what you're looking at. Okay? And I'm going to try to help you guys understand that right now because it's important. You see up here, positive, negative. There's a pretty decent amount of distance between those two. So they're really not like right next to each other. Now these things are flaring, okay? But in order for these things to flare, they got to be touching. I mean, this stuff has just got to be crossing all over itself, right? And so if we go down here and we start looking at this one that just, this one here actually blew one off also, okay? And these are the ones that were blowing it off kind of to our, would be to the west when you're talking about looking at the sun. It's backwards of what you would say here on the planet, on our surface here. It's not like looking at a map. When you're looking at the sun, east-west is actually reverse, okay? I know it sounds asinine or whatever you want to call it, but that's just how they do it. And there are reasons behind it, and actually decent reasons. I'm not going to go into it, but so watch this sunspot here. See how you got negative here, and watch the positive just like surround this thing. Okay, and watch it all just start to grow, and it starts to intermingle. When these things intermingle like that, it flares. This thing is in a constant state of snapping flares off right now. Okay, so that's what we got now. We went from there. We back this up a little bit. You're talking probably 12 hours from there to there. That's how fast these conditions can change. Okay, so when you have this like this surrounding, this thing is not going to stop flaring. And there are signatures here now suggesting that it's possible for X-class flares to come out of this thing. Okay, I'm not saying that it's going to happen. I'm just saying that it's possible. So, but we're definitely seeing M-class already. So, you know, take that for what it's worth. But again, like I say, most oftentimes, nothing's 100% ever. It's just not. Things can change in the drop of a hat. Things can get better, get worse, whatever your point of view is. You know, if you're an aurora photographer, this is a good thing, right? If you're a first responder and rely on radio for your communication, geomagnetism isn't such the greatest thing to have. So what's good for one group is bad for the other. Now, yes, if we're going to be talking like a grid down situation, that's bad for everybody. I get that. I'm not trying to say that. I'm just saying in these kinds of conditions I'm talking about, those are the people who it's infected. So anyway, this is the 304. Now I'm just going to grab it and kind of drag it across. Okay, you seeing it flare here? I'm going to zoom in a little bit. Okay, so you see that flare right there in the middle? This is that one, right? Now there's some eruptions over here too, and a filament release up here. And I'll take you over to seeds and show you guys that here in a few minutes. But look at that one. Okay, that's a substantial flare. Look at all this stuff, and the sun's just completely active right now. And I showed in my last video, we had kind of that, let's see it do it again? That's what I said. This thing is, and it's not just this spot. It's multiple spots flaring. There's another one. Now you can actually see that one actually, you can see the plasma leaving right there. Just a little bit. It picked it up. See that kind of blow off there like that? Okay, and that's, right now, that's the current capture. There's another eruption happening right now. It hasn't been showing up on the other tools yet. I'll refresh this real quick and see if we can't get another, see if it'll give us a couple more images here. There's that first eruption right here. Check that out right there. I'll grab it right here. See, right, see that? Bam. Notice how this spreads out across the surface right here too. This energy, this plasma. See that? And there's another one. Another one. Another one. Decent sized one there. Okay. Okay, and this is what it looks like right now. It looks like it's erupting again, guys. Okay? Now, I'm not going to say that it's any kind of big-time flare or CME. I can just tell you right now that that's actually erupting right now. That's, yeah. Now, whether that stuff is able to leave the sun, don't know yet. But it could. So we'll just have to keep an eye on it. But, you know, and again, guys, that's just what we have to do. Now, there's that was my thumbnail capture right there. And the 211 here shows this coronal hole really well. But something else that's showing really well right now is you can see the energy ripple across the surface, or at least the corona, I should say. I don't know that I would call it a solar tsunami, because I don't know that it's that intense. But you can definitely see right here, when this thing erupts, you'll see it kind of roll that way. And so what I'll do is I'll just go up here, and we'll do it this way. So you can kind of see it every time it erupts at all. You can see it disrupt the corona. Okay, so if we go forward, wham. Okay, now see, that was that bigger one that didn't really go right at us. We may catch a glancing blow from that one, but notice how it disrupts the corona. I mean, like all the way up into here. Okay, so if we move on, and right here is where that bigger flare came from. See that? You see what happened when that flare blew off? Watch. See that kind of hazy part here? Bam. I mean, and then it does it. Look, it's doing it again right there. Bam, bam. I mean, this thing is just constantly erupting right now. And I don't look for that to change anytime soon. I really don't. Judging by what the complexity of that sunspot is, I don't see it changing. At least not, you know, it could change at the drop of a hat just like it grew. But what we're looking at right now, it doesn't look to be. So that's what I'll say to that. All right. So let's take you over here to seeds real quick. Let's go take you to the 14th. Okay. This is LASCO C2. It's a satellite, sits out in front of our planet, about 1 million miles closer to the sun than what we are. Always looking at the sun, and it orbits with us around the sun. So, yeah. So this is the 14th, and we get kind of a halo shot here. This is a black occulter disc. It's an actual disc on the camera. Its job is to block out the corona of the sun so we can even get a capture at all. If we didn't have that, it would be just get flooded with light, overexposed. We wouldn't be able to see anything. Just be a big white blur. But yeah, so that's the 14th. Couple eruptions there. So let's go to the 15th. Okay, you're going to see a couple more. Bam. Bam. This stuff just kind of, you know, I get amazed real easy over this stuff because I like looking at it, right? But those are sizable eruptions. Now we go from 1300 to, that's 4 hours later. There's about 4 hours of missing time right here. So that thing didn't move that fast is what I'm trying to say here. All right. So if we keep moving forward. Now, what I'm going to do, because oftentimes, like I've shown you guys here before, we're able to see more if we go here. But we may not. I don't think we're going to this time because if you look at the date, it's the 15th and 2000 hours there. So not really any sense in showing you that. But I guess I could click on it. It's not a big deal. This is when it detects the CME, it throws it down there. It takes a little clip and pulls it down there, a few of the images. It's real easy to see where the CME is if you use that chart. Okay. But yeah, so you know, we're looking at 4 or 5 different eruptions. A lot of it's coming right at us. How do I know that? Well, okay, this is my video from yesterday or earlier today or whatever. This is the CME tracker. Okay. So what this is showing, and I'm just going to push, I'm muted there, so I'll just push play. Okay, see what it's showing there? It's another eruption. And that's coming right at us. That was that first initial one. So with that being said, let me show you the up-to-date one, because now this is the up-to-date one, and this is a different eruption. This one's showing, and obviously the size of it, as far as like big and wide, isn't quite as big, but it still is directly hitting us. Now, if you look at the side cut here, you can see how it's actually going to sail south of us quite a bit. So this is not going to be a direct hit. It would be more of a side hit, if you want to say it that way. The top of the CME is going to clip Earth, according to this model. Now, NOAA's model does not exactly agree with this, and I'll show you here in just a second. I'll go ahead and get rid of that one. I get rid of those guys because it slows the stream down. So anyway, oh, this was interesting too. You see this? This is the same. This is the LASCO C3, which is the Soho Observatory, like I showed you guys a minute ago. But this has just got a wider view. The field of view is wider. Okay, it's kind of zoomed out, basically. Look at this. You see, it looks to be two separate eruptions. It probably is. Back-to-back booms. Okay? But that's what that looks like here. I just thought that was interesting, so yeah. This is NOAA's model of that model I just showed you from NASA. Okay? This is the same model. This is NOAA's version of it. And it's showing you the same thing, except for this here. It gives you 2 days historic data, and then it tries to forecast out 5 days in advance. Oh yeah, we got new flares, guys. It's not going to stop, guys, and that's what I'm trying to say. It's not going to stop. At least anytime soon. The next couple of days, we're going to have to really watch. So please bear with me on that, because yeah. So I'm going to grab this, and again, you got density at the top here, and you got speed here on the bottom. NASA model, it was the end little spiral, NASA's version of it. This thing here. Okay, it's the same model. It's just set up a little different, and they take different data points into consideration at different levels on each model. So NOAA takes certain things more serious than others, with data being entered into the model itself. Okay, so they're able, and what happens is sometimes they agree and sometimes they don't. Right now they're not completely agreeing, so you know that causes us to be like, yeah, let's pay a little bit more attention, right? Because that's telling you that not everything is being agreeable. So there again, there's an eruption, and you can kind of see a second one pop off there. So yeah, but they're both showing a hit. Okay, and you can see here too, if you look at the line graph, same thing. A higher dense around the 18th, and that's when they're predicting the G2. And if you look here, you can see where the speed kind of spikes up. Now the green line's the conditions at Earth. Red line's conditions at Stereo A, which is the side view I show you guys all the time. Okay? So if we go here, what can we expect, guys? I'm not going to read this. If you guys want to take a screenshot, please do. But I do think, guys, that if we get into G2 and G3, and if something else happens, like we get an X-flare, there's probably a decent chance we'll get higher than even that. I'm not going to say that that's going to happen because I just don't know. But yeah. Yeah, Space Weather Prediction Center is the site. I'm sorry, guys. Thank you, Mark, for answering that question. So, yeah, guys, you got this. You know, you can go over here to Space Weather Prediction Center, and I'll show you real quick. How about that? This is Space Weather Prediction Center. It's NOAA. That's all you got to do is Google it, right? And it'll get you right here. And this is the main dashboard for space weather. And if you scroll all the way down, you're going to find right here, products and data, models. See these models? That's about everything I show you. All you got to do is click on these links. and it'll take you to start looking at it. I mean, honestly, like this right here, it's the LASCO. See? It shows you C2 and C3 right next to each other. So if we push play, there you go. You can kind of compare the wider angled view to a more zoomed in version here on the left. I don't typically use this one because I like to give you guys more of a zoomed in look, but this works just as well. So yeah, there's all kinds of links over here, guys. Go check them out. Can't hurt. You can't find the NASA model? Okay, hold on 1 minute. I'll get it for you, okay? I'll post a link in there, okay? Give me 1 second. It's going to be a long one. I don't know if it'll take it. We'll see. Let's see if it takes it. Hey, okay, it fit. All right, there you go. That's a long one, but it's there, okay? Just click on that link. It'll take you over here to the NASA version, all right? So, yeah, spaceweather.com. Go give them some love. They're talking about the same thing here. Yeah, see, they're even talking about G2 now, too. So, and this is just, well, here's the, talking about the opposite polarity and all that kind of stuff. Remember, guys, we get opposite polarity about 3% of the sunspots in any given sun cycle. And those spots do have a tendency to flare more often. Now, they don't have a tendency to be blowing off like humongous ones. Not to say that they can't, because they can. But typically, they're just rapid fire, is what I'm trying to say. So, and again, the coronal hole. We've just got so much stuff coming at us right now. It's just going to be hard to be able to pinpoint how strong or when it's exactly going to happen. But I'm going to be here. I'll try to, keep you guys up to date. So, just want to make sure everybody's got, knows that that's happening. So, yeah, that's really all I got for you guys. If anything else happens, I definitely will be back on here. I appreciate everybody just coming and checking me out. Go check out everybody that, that we talk about. Again, over on the Lifeboat, that's where I go. It's our addiction recovery channel. Come check us out. It's called the Lifeboat. And we had a pretty good stream tonight. A lot of good conversation and a lot of good, good stuff to help people through things. And but yeah, you get to see a lot of forgiveness. And that ain't typical. We don't typically get a whole lot of forgiveness in this world today, guys. But we give it over there. Okay? There's no judgment over there. If you have any curiosity about drug addiction and recovery, if you know somebody you love, if you yourself are in addiction, please come over and check it out. You ain't got to stay, but just come check it out. And if you don't like it, cool. But I've not had anybody come back to me and say, "Hey, that sucked," because it doesn't. Because you're welcomed as soon as you walk in the door. No judgment. Matter of fact, Flamin was in here earlier, I think. He'll tell you he loves you right when you walk through the door, and he means it. And I'm not kidding. We don't judge people over there. So, anyway, hope you guys go check that out, and I'll keep you guys up to date with space weather. Go check out Marv. I'm thinking they're going to be live here in just a few minutes, probably here in an hour or so. Yeah, Rip and everybody else I talk about. And thank you to all the people coming over from Pastor Paul Bagley's channel. Go check it out too. All that stuff, guys. Go check everybody's stuff out. Find what you like. Don't be so quick to judge everybody's stuff. Go, if you don't, what I find when I go watch other people's channel, I don't typically agree with everything that people say, but I do agree with some of it. So, you know what I mean? And I think that that's healthy. It takes all of us to get, to be here and do this and do it in a respectful way. And we just got to do that. Just drop all your baggage at the door and just try to look at something and be happy, You guys know I'm a Christian, and that's where my base is, and I don't push that on people, but that's part of why I'm so positive most of the time. Because I try to be. It's not something that just comes natural to people, guys. You got to work at it sometimes, and then it becomes natural. So, anyway, guys, love you guys. I will definitely see you guys tomorrow. And we will come back on here if there is any kind of updates or anything. And we'll see that in just a second. Oh, crap. There went my chat. Sorry, guys. I was going to try to say hello to you guys again. Anyway, guys. Goodness. Oh, okay, there's my chat. Okay. Bag and Lie. Oh, no, Bagley. It's Bagley, guys. Hey, Sid. Paul Bagley. Go check out his channel. Check out everybody's channel. I'm telling you. You know? Really. Just get happy, you know? Well, look, just go love on everybody, and you'll be surprised how much better your life is. Promise. I ain't telling you got to agree with everything I say. You know? But just give everybody a chance. And, you know, there's a red button. It's got an X up there in the right-hand corner. If you don't like what you're looking at, you don't have to look at it no more. You know what I mean? So, but, anyway, guys. Love you guys. See you guys probably tomorrow sometime if we get any more flaring, which I think we're going to. So, I'll see you guys tomorrow. And God bless. Yahusha saves. And you can drink this Kool-Aid.